Hi everybody, we are going to take another look at our guessing game program, but we're now going to start applying this concept of abstraction. And when we talk about abstraction, it's simply the idea that we can take a bundle of code, give it a name, and take some of that complexity and dish it off somewhere else so we don't have to think about it when we're looking at our main program. So it's appropriate to look at this guessing game program in Java because Java tends to have a little bit more syntax and a few extra lines of code, often to do sometimes pretty simple things. So if we look at our guessing program, there was a couple notes we put. We wanted to generate a number, which we did on this line. And then on this line, we printed it out just for testing purposes so we could see the answer. And then we said we want to have the user guess until they're correct. So these two lines here, and actually this line up top on line 6, all three of those lines are used just for allowing us to get a person's input, to get their guess. And right now, it actually doesn't work that well. So I'm going to show you some of the things that are wrong with it. Let's run our program. And just as a reminder, the program currently generates a number from 1 to 10. And when we are prompted to enter a number, we can enter a lot of different numbers that maybe we don't want to allow the user to enter. For example, we could enter a number up to 100. We could enter a negative number. So, for example, let's type it in right now. We know the secret number is 3, but I could enter 10,000, and it would just say wrong. I could also enter negative 12. I'll just say wrong. I can even enter a word. Now, when I enter a word like cat, I break the program. The input wasn't expecting that. Now, we can fix that. This is now a known bug in our program, and we can write code to fix it. But what that's going to do is it's going to end up making our program longer. And right here in the middle. So let's just say, hypothetically, if we added 5 or 6 more lines of code, now our program has gotten pretty big, and we end up having this section right in the middle that is just there to get a guess from the user. We don't really need all that space used up. What we can do is replace it with a single line, a method call, and then move that code somewhere else. So I'm actually going to cut this text out for a moment. So using Control X, and instead what I'm going to do is say int user num, or user guess is what we called it, equals get guess. I'll put parentheses there, and we are in a semicolon to end that line. And what I've just done is called a method that right now does not yet exist. There's already some examples of calling methods other places in the program. For example, math.random is a method call. There's actually a lot of lines of code that are being run when we call that, but it was written somewhere else, and we're just referring to it. Same thing when we say sc.nextInt. A lot of lines of code are being run. And even when we do these print statements, we are calling methods. The telltale sign of a method, at least in the Java language, is when you see a set of parentheses after a phrase. So let's take this get guess and define it. We're going to create our own method. And to do that, what we'll do is go up to the top of the program, give ourselves a little bit of room. So we're inside the class, but we are outside of the main method. Here's another example. Main is also method. There's your parentheses for arguments, and here is the code associated with it. So what we are going to do is create another one, public static, and we're going to say int, because this method getGuess is going to return an int. So this is called the return type. And right here, the void for main is the lack of a return. A main method just executes and no information is passed back. So it's a void type. Although in some programming languages like C++, for example, it wouldn't be void. It would actually be an int return. But we are going to write the getGuess method, put parentheses in, and we're just going to go ahead and paste that code from earlier. Now, you'll recall that I did say there's actually 3 lines of code associated with getGuess, this line from 6 up here. So we're going to take that out and put it up here. And then we're also going to change this last line a little bit. Instead of declaring a variable and getting an extent, we are just going to say return sc.nextInt. So return means take some information, send it back to the place that called you. So if I were to ask you, think of a favorite food, you would think about it. You might run through memories in your head of things that you like to eat, and eventually you would land on pizza, and you would return the word pizza to me. You would send that information back. So this method is going to do the exact same lines of code we did before, and then return an integer. So this method call is basically like an int. User guess equals an int. It's an int method, not an int type, but that's the same thing. They're interchangeable. And we can also go down here and call it again. So we'll go right here. Whoops. Sorry, I had the wrong thing pasted. We're just going to call it get guess again. Instead of sc.nextInt, get guess. And let's take that part out too. All right. So if you look at this part of the program, it's actually shorter than when we started. But if we run our program, it's going to do the same thing. Now, I know we started out by saying we were going to try to fix it, but I want to show you that we didn't break it first. So I enter a number, and I can still type in 10,000. I can still type in -12. And if I say cat, it'll still break. But the important thing is it's still working. So we haven't broken anything. All we really did was move a bit of code up here, and then give ourselves a place to work. Now, it's a very good habit, and something you should always do, to have a code block or a comment block above a method describing what it does. And in Java in particular, we make a code block with a /** to begin with, and end with a /*. That double star to begin with is basically a little note for the compiler to create documentation, but we don't need to go into that now. And what we're going to do is just write a little note to ourselves about what this method should do. So this method will create a scanner, prompt the user, oops, don't want that, to type in an int, and then return it. All right, so that is the main emphasis of the method. But we want to fix it up a little bit too. We want it to be a little bit better at getting an int than previously. In fact, the big thing we want to do is prevent it from breaking when we type in text. So there's actually a nice and easy way to do that, because scanners are able to do a lot of things other than just tell you what's at the keyboard. They could check to see what's there and what type it is. So we can actually write a while loop here that says while sc.hasNextInt, while that is false. What that means is while the thing being typed in is not an int, we can say, well, let's print out a message here, and we'll just print out not an int. And how about please try again? And then we're also going to say sc.next, just to tell the scanner to skip the thing that it's currently looking at. Now, after we do this, when we leave this while loop, it means that there is an extent, and then we can return it. So let's try running our program now. And with Java, of course, it takes a little bit of time to compile and REPL, so we'll just wait for it to go. All right, and our number, now I can still type in 10,000. I can still type in number 12, but now if I type in cat, it's going to say that's not an int, please try again. And instead of crashing and breaking the program, I'm just caught in this loop that won't let me continue until I type in a proper int. So let's type in 10, and it's happy I didn't break the program. So what we just did was add some lines of code that prevent our program from crashing. But again, you can see it's starting to get pretty long up here. And our main program doesn't need all this stuff in there. It's a lot easier to read the main program if we say, well, there's a count, and then we get a secret number, and then, oh, we get a guess, and we can infer what's happening there. We can infer that, well, a guess is getting retrieved from the keyboard somehow. And we can assume there's some error handling and whatnot going on. And if we're not really sure how it's done, we can go up and read this message that tells us what the method does. So let's add to our message now that there is input validation to ensure the input is an int. All right. Now, we can still go out of a range, so we probably want to fix that as well. So what we could now do is say, while it's not an int, try again. And what we could also do is check to see if it's too big or too small. So one way to do that is we can go down a little bit further, and we're going to actually do a different type of looping here. We're going to say if the, let's see, actually we're going to take this sc.nextInt out of here. So let's say, we'll call this a temporary variable. Int temp equals sc.nextInt. And now what we're going to do is say if temp is less than 1, or maybe we'll say less than 0, we could put in a message. Please don't type in a negative number. But no negative numbers. And instead of having a while loop, what we can do instead is call this method again. This is called a recursive call. So we're going to call getGuess. And we're going to say return the response to getGuess. And the reason it's called a recursive call is because we have the method creating a new instance of itself and running again. So kind of going deeper into this hole. Now, if the temp is not less than 0, if it's a positive number, then we can just go ahead and return it. So what's going to happen is we're going to keep calling versions of getGuess until eventually we have an acceptable number, and that number will be returned. And if we did the recursive call, it'll get returned from a recursive called version of method. But now look, we're at about 15 lines of code just for getting a guess, but we are making it a little better. So let's try running again. And again, we'll have to wait for it to load. But let's try 10,000. And that is still acceptable. Enter a number. If I hit negative 12, it's going to say no negative numbers and prompt me to enter it again. Negative 5. I could try cat. I could try dog. Negative 12. And it's still not letting me until I hit 5. And let's go 7, which is the correct answer. So we now have even more error handling. Now we're making sure that we don't put negative numbers in. And testing like this is very important, especially in programs where weaknesses can be exploited to do things that you don't really want. For example, imagine you had a computer program where a bank teller had to input the amount of money being deposited to an account. Well, depositing a negative amount would be actually making a withdrawal from that account. That could be a big problem. So input validation is always very important. Now let's do one more step to this, and let's put a limit to say that there's a maximum number for which you can't go over. Now in our program, the max is determined by the number 10 right here. And let's make this a little bit more sophisticated. So we're going to actually create a max. We'll call it 10. So right here we can write max. And then when we call getGuess, we're also going to put in this term max as what's called a parameter. So you're sending information to the method. Those parentheses are a means for you to send parameters or arguments to the method. Now, it's giving me an error message right now because getGuess does not expect to have an argument, doesn't expect to have a parameter. And that's because when I declared getGuess up here, I didn't tell it that it would need that. So let's have a int max, and we'll put that in. And now, when we call getGuess here, we also need to make sure we put that pass in. But what we could do is say, well, if the temperature is the temporary variable is less than 0, we have an error. But also if, or otherwise if, temp is greater than max, we can also have an error message and do a recursive call. So this time what we can put is that is beyond the max of max. All right. So now what we have done is created a floor, negative numbers, a ceiling, the maximum number, and prevented text inputs when we expect a number. And again, this method has gotten pretty big. Now we're up to 19 lines of code, not including the description up here. So imagine if those 19 lines of code were here and here. It would make this program very messy and very hard to read. So we use methods to capture a lot of lines of code and put them somewhere else so that we can just call them when it's convenient without having to rewrite them all the time. Sort of like when we learn how to do something like a jumping jack. The first time you do it, you need the instructions for how to move your arms and how to move your legs. But once you learn what a jumping jack is for the rest of your life, all you need to do is hear that phrase jumping jack and you know what to do. So again, let's test our program. This time we're going to try again 10,000. And now it's telling us it's beyond the max. If we do -12, it says no negative numbers. And if we say cat, it says not an int, please try again, which is forcing us to do it correctly. So let's put in a 6, a 7, and then 5. And it still is only counting my 3 actual guesses. So it is working correctly the way that we left it. This main section of our program is about the exact same length as when we started, but our program as a whole is about twice as long and a lot more sophisticated. Yet, by using a method, we've kept it nice and organized. So that is the value of methods. Bye now.